conventional phase modulation, except with PSK. The input is a binary digital signal, and there are a limited number of output phases possible depending to the levels of an M-Mari. So also the input binary information is encoded into groups of bits before modulating the carrier. And lastly, like any form of shift keying, there are defined states or points that are used for signaling the data bit.
One of its type is 16 PSK. It is an MRL coding technique where M is equal to 16, in which there are 16 different output phases possible. A 16 PSK modulator acts on an incoming data in groups of 4 bits. 2 raised to 4 equals to 16, called quantities. In this project, 16 PSK will be generated through Simulink. To do so, several blocks are used and connected to each other to form a system. This will be explained during the simulations.
The program contains two different connections. For the first connection, it is the generation of constellation diagram of the 16 PSK. For the second connection, it is the generation of XY graph of the 16 PSK. For the first connection, the constant block serves as an input. The constant block contains 0 to 15 integers. This was converted into row vector by the vector concatenate block. The output of the vector concatenate block was connected to MATLAB function block, namely custom decimal to binary function. In this function, the output of the vector concatenate block is converted into binary numbers. We use the display block to view the input converted into binary numbers. The output of the vector concatenate block is connected to the MPSK modulator baseband block. All the process for 16 PSK modulation was done here. The output of MPSK modulator baseband block is connected to the constellation diagram block. By this, the constellation diagram of the 16 PSK can be generated.
To view all the output, different display blocks are attached. Those display blocks named as equation, magnitude, and phase. The equation display block is directly connected to the MPSK modulator baseband block. The magnitude display block is connected first to the complex magnitude angle block before the display blocks. In the complex magnitude angle block, there are two outputs, the magnitude and the phase in degrees. The output magnitude terminal is connected to the magnitude display block, while the output phase terminal is connected to another MATLAB function block, namely as custom phase function. By this, the output phase of the complex magnitude angle block will be converted from radians into degrees. After converting from radian to degrees, this was connected to phase display block. By that closed system, the constellation diagram, truth table, equation, magnitude, and phase can be simulated.
For generating the XY graph, we use random integer generator as input to the MPSK modulator baseband. Since the output of the 16 PSK modulator baseband is a complex number, complex to real imaginary block was used. Then the output of this block is connected to the XY graph. For the second Simulink program, it has an objective to determine the mean error rate of the 16 PSK modulation. There is random integer generator block that provides the input of the system. It is connected to the MPSK modulator baseband block to have a 16 PSK input. The output of the MPSK modulator baseband block is connected to the AWGN channel block to provide statistical noise having a probability density function equal to that of the Gaussian distribution. The reason why the noise is added in the 16 PSK input is to test if the 16 PSK input can tolerate noise in the long run of modulation. After that, it is connected to the MPSK demodulator baseband block to bring back the 16 PSK input. Using the error rate calculation block, the error before the modulator and after the modulation will be calculated. This was displayed through the display block.